Algebra Lesson 9-7, Factoring Special Cases. Now, you can factor special cases just like we factored before, using the forms for x squared plus bx plus c, or the form for ax squared plus bx plus c. Or you could recognize that they're special cases, and that way you'll speed your time up. Either one works as long as you factor them. Let's take a look at the first couple of examples here. If I have an x squared plus 6x plus 9, I need a product of 9 and a sum of 6. I'm thinking 3 plus 3. That works. 3 times 3 is 9, and 3 plus 3 is 6. That gives me x plus 3 times x plus 3. Or I could rewrite this as x plus 3 quantity squared. If I'm looking at m squared plus 12m plus 36, I need a product of 36 and a sum of 12. That's 6 and 6. So I'm going to have m plus 6 times m plus 6, or I could rewrite it m plus 6 quantity squared. And the last one, k squared plus 10k plus 25. I need a product of 25 with a sum of 10. That's 5 and 5. So I'm going to have k plus 5 times k plus 5, or otherwise known as k plus 5 quantity squared. Now, as you can see, these are actually all squares of a binomial. Remember in lesson 9.4 when we were doing multiplication and we used special products to multiply? You can use those same special products, but in reverse, to factor. We learned that a plus b quantity squared is the same thing as saying a plus b times a plus b, or a squared plus 2ab plus b squared. We also learned that a minus b quantity squared was a minus b times the quantity a minus b, which equals a squared minus 2ab plus b squared. Any trinomial in the form of a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared, is a perfect square trinomial. You can factor those perfect square trinomials into two identical binomials using the formulas here I have in the box under perfect square trinomial. You should definitely make sure that this is in your notes. These will come in very, very handy. Now, how do I know if something is a perfect square trinomial? You can factor it using the grouping method we learned in 9.6, or you can, if you recognize it's a perfect square trinomial, you can use the formula to factor it faster. How do you recognize if it's a perfect square? First thing to look at, the first and last terms must be perfect squares. Okay, the first term has to be something like 9m squared, or 25t squared, or just x squared. It has to be a number squared and a variable squared, or just a number, or just a variable squared. There must be no minus signs in front of your a squared or your b squared term, and the middle term must be twice the product of one factor from the first term and one factor from the last term. In other words, it needs to be 2ab or negative 2ab. Let's look and see if you can recognize if something is a trinomial square. Okay, so it says, which of the following are trinomial squares? Let's see here. Is my first term a perfect square? Yeah, it's x squared, x times x. Is my last term a perfect square? Yes, 1 is a perfect everything. Perfect square, perfect cube, perfect everything. So this would be x times x, and this would be 1 times 1. So 2 times a times b would be 2 times x times 1, which is 2x, which means, yes, this is a perfect square trinomial. Because it fits the fact, it fits the criteria. The first term is squared, the last term is squared, my a term is x, and my b term is 1, and the middle term is 2 times 1 and times x. Okay, let's look at number 2. Is my first term a perfect square? Yes. Is my last term a perfect square? Yes. Okay, if I look at this, my a term is x and my b term is y. Is my middle term 2xy? No, my middle term is 3xy, so no, this is not a perfect square trinomial. Middle term is 2xy. Middle term should be 2xy if it was going to be a perfect square trinomial. Let's look at number 3. Is this a perfect square trinomial? Is my first term a perfect square? Yes. 81x squared goes down to 9x. Is my last term a perfect square? Yes. 4y squared goes to 2y. My middle term would be 2 times 9 times 2 times the x times the y. 9 times 2 is 18 times 2 is 36, so it should be 36xy. Is my middle term 36xy? Yes, it is. So yes, this is a perfect square trinomial. It would factor to 9x plus 2y times 9x plus 2y very quickly. Let's look at number 4. Is this a perfect square trinomial? Is my first term and last term a perfect square? Yes. However, there's a negative sign in front of my b squared term, so no, this is not a perfect square trinomial. Last term is negative. All right? You can't have a last term negative. Look at number 5. 4x squared plus 20x plus 45. Is my first term a perfect square? Yes. My a term is b2x. My b term, is that a perfect square? Yes, that's b5. There's no negative signs in the entire problem, so we know there's no minus signs before my my a squared term or my b squared term. Is the middle term 2 times 5 times 2x? Yes, it is. 5 times 2 is 10x, plus times 2 again is 20x, so yes, this is a perfect square trinomial. If you can recognize that things are perfect square trinomials, you will be able to factor them faster. You can always go back to factoring by grouping, but if you can recognize their perfect square trinomials, it will work much faster for you. Let's take a look at this first one. X squared plus 2x plus 1. I know that's a perfect square. My first term is a square, my last term is a square, my middle term is 2 times x times y, right? Or 2 times a times b. So my a term here is x and my b term is 1. So since this is a plus, remember the two formulas are a squared plus 2ab plus b squared, which factors to a plus b times a plus b. And then we have a squared minus 2ab plus b squared, which factors to a minus b times a minus b. Since I know this is a perfect square trinomial, and it happens to be all positive, it's going to be the first formula I wrote down, so it's going to be x plus 1 times x plus 1. Or you could write it as x plus 1 quantity squared, and mean the exact same thing. Let's look at number 2. Is my first term a perfect square? Yes. Is my last term a perfect square? Yes. 8 times n is 8n times 2 is 16. Yes, it is. It's a perfect square trinomial. Fits into the second formula because it has the minus sign here. My a term is n. My b term is 8. Because the square root of n squared is n. The square root of 64 is 8. So I'm going to have n minus 8 times n minus 8. Now let's say you didn't recognize it as a perfect square trinomial. Can I factor it like we've done before? Yes. If I looked at n squared minus 16n plus 64, I would need a product of 64 with a sum of negative 16. I'm looking at negative 8 and negative 8. So I would have n squared minus 8n minus 8n plus 64. Group first two. Make sure this is a plus the opposite. And then the last 2, that's a negative 8n. So I can take out of here, I can take out an n, and I get n minus 8. Here I can take out a negative 8, and I get n minus 8. So my common term is n minus 8. What I'm left with is n minus 8. You'll still get the same answer. It's just that this, if you can recognize it's a perfect square trinomial, it's much, much faster. Look at number 3, perfect square trinomial. Yes. My a term is t. My b term is 7. Since it's a minus sign, it's going to be t minus 7 times t minus 7. If you can recognize them, you'll be able to factor them so much faster. So look at 25x squared minus 70x plus 49. Perfect square for the first term? Yes. Perfect square for the second term? Yes. My a term would be 5x, and my b term would be 7. 5 times 7 is 35, times 2 is 70, so yes, this is a perfect square trinomial, because my middle is negative 2ab. Since there's a minus sign here, this is going to be a minus problem. 5x minus 7 times 5x minus 7. If we look at number 5, you're going to look at that and go, hey, she learned the first term is not a perfect square, and the last term is not a perfect square. Because it is not. But perhaps, is there a common factor we need to take out? Do they all have something in common? Let's see here. The second and third term is divisible by 5, but the first term is not. But I'm looking at this going, 8 and 4 is 12, that's divisible by 3. 2 and 1 is 3, that's divisible by 3. 7 and 5 is 12, that's divisible by 3, so it has to be divisible by 3. I'm going to take a 3 out of this. If I factor a 3 out of everything, I'll get 16m squared plus 40mn plus 75 divided by 3 is 25, 25n squared. Now, look at that. That's a perfect square, isn't it? Because my a term, if I just look at the 16m squared plus 40mn plus 25n squared, my a term is 4m, and my b term is 5n. 5 times 4 is 20, mn, double that is 40 mn, so it's a perfect square trinomial. So this would be 4m plus 5n times 4m plus 5n, and don't forget we took a 3 out of it, so put the 3 back into it. If we look at number 6, we have the same thing. The first term is not a perfect square, but we can divide everything by 2. If I divide everything by 2, I'm going to get x squared plus 6x plus 9. My first term, a is x, my b term is 3. 3 times x is 3x, times 2 is 6x. It's a perfect square trinomial. Everything is added, so it's an x plus 3 times x plus 3. And don't forget we had a 2. Again, you can factor using the method we learned in 9-6. It will just take a lot longer. This is a lot faster if you figure it out. Now, also recall from 9-4 that when we multiplied a plus b times a minus b, we came up with a squared minus b squared. So you can factor the difference of 2 squares as an a plus b times an a minus b. To factor the difference of 2 squares, 2 things must be true. There must be 2 terms, both squares. The first term and the last term must be perfect squares, like 4x squared, 9x squared, 16y squared, 36, 81c squared, etc. There must be a minus sign between the 2 terms. It does not factor if there's a plus sign. Only works if there is a minus sign. So the difference of 2 squares has to have this minus sign right there. And it will always factor to an a plus b times an a minus b. So let's factor some. Oops. I don't know if I have this. Oh, let's go to this page instead. Let's factor this. X squared minus 36. 2 terms. First term is a perfect square. Last term is a perfect square. The square root of x squared is x. The square root of 36 is 6. So I have x plus 6 times x minus 6. Or x minus 6 times x plus 6. It doesn't matter which order you put them in. One has to be plus, one has to be minus. Okay, m squared minus 100. My a term is m. My b term is 10. Square root of 100 is 10. So I'm going to have m plus 10 times m minus 10. How about p squared minus 49? Okay, perfect square, because p squared is square root of p squared is p. Square root of 49 is 7. So we'll have p plus 7 times p minus 7. Okay, number 4. My a term is 2w now, because I have a number here. My a term is 2w. My b term is 7. So I'll have 2w plus 7 times 2w minus 7. Perfect square trinomial. I have a difference of 2 squares. Okay? And a few more examples. 32x squared minus 50y squared. Wait, you say, those are not perfect squares. They're not. Can you take something out of it? Yes, I can take a 2. If I take a 2 out of 32, I'm left with 16x squared. If I take a 2 out of 50, I'm left with 50y squared. 25y squared, and I divide it actually by 2. 25y squared. Now they're perfect squares. Okay, my a term is 4x, my b term is 5y. So I will have 4x plus 5y times 4x minus 5y. And don't forget you took a 2 out of it, so put the 2 back into it. You might look at number 6 and go, yeah, that one looks terrible. It's because it can be divided by 5. I take a 5 out of that. I'm left with 1 minus 4y to the sixth. So my a term is 1, and my b term, be careful here, is 2y to the third. We just divide the variable in half. Okay, 2y to the third. So this becomes 1 plus 2y to the third times 1 minus 2y to the third. And don't forget we took a 5 out of it, so we have to put the 5 back into it. Number 7. It's an interesting problem. 81x to the fourth minus 1. And my a term, let me do this in a different color. My a term is 9x squared. My b term is 1, because the square root of x to the fourth is x squared. You divide it in half. So this becomes 9x squared plus 1 times 9x squared minus 1. And you might think you're done here, but unfortunately you are not. 9x squared plus 1 will never factor in because it's the sum of two squares. But if you'll notice, the 9x squared minus 1 is still the difference of two squares, isn't it? My first term is still a perfect square, 9x squared, and my last term is still a perfect square, 1. And there's a minus sign between them. So I can factor this to be 3x plus 1 times 3x minus 1. So the entire thing factors to the 9x squared plus 1 that we took out to begin with, and then the 3x plus 1 times the 3x minus 1. And we really moved into the next problem, so I'm just going to move the next problem down a little bit. I'm going to do it over here. So problem number 8 says 16n to the fourth minus n to the eighth. Okay, so perfect square, my a term is 4m squared. My b term is n to the fourth. So I will have 4m squared plus n to the fourth, 4m squared minus n to the fourth. Never factors again because of this plus sign. This is a perfect square binomial. Okay? Binomial square because 4m squared is a perfect square and n to the fourth is a perfect square, and there's a minus sign between them. Okay, so this would factor to 2m plus n squared, 2m minus n squared. Neither one of those factor again because this is not a perfect square, so then we can just write down the 4m squared plus n to the fourth that we took out to begin with, and this is the final answer to that factoring. And very important that you make sure that you factor all the way. Okay? If you can recognize that things are special products, they are factoring by special cases, then you can speed your factoring up by a great deal. So the faster you can recognize that, the better off you will be. If you can't recognize it and you have to factor by grouping, you can get it factored, but it will take quite a bit longer.